We're going to look at another example of finding a polynomial function when we're given the zeros of it. So if we want to find a polynomial function with integer coefficients that has 2, 4 plus I, and 4 minus I as zeros. Again, notice that they told us, they were very nice in this list, that 4 plus I and its conjugate 4 minus I are zeros. Anytime we have something with an imaginary number as a zero, its conjugate is also a zero of our function. So here this looks like a complex number that has both the real and the imaginary part. So this is going to make what we do a little bit strange looking, but we still go through the same process. So to write our function, we're going to call it some sort of function name, f of x, g of x, h of x, whatever you like. We'll take our zeros and we'll write them as factors. So if 2 is a 0, x minus 2 is a factor. If 4 plus I is a 0, then x minus that is a factor. So we'll have x minus 4 plus I as a factor. Notice I'm putting that 4 plus I in parentheses. Same sort of thing with 4 minus I. If 4 minus I is a 0, then x minus that number, minus 4 minus I, is a factor. So now we're going to take the negative and we're going to distribute it to both terms of those complex numbers. So we'll have f of x equals that first factor of x minus 2 stays the same. This is going to become x minus 4 minus I. And this one will become x minus 4 plus I. So we want these two things to look like conjugates so that when we multiply them, the inner terms cancel out. So if we look at these right now, we could consider the x minus 4 to be the real number part. It looks exactly the same on both of them. And then the I would be the imaginary number part. Looks the same on both of them. One of them has a plus, one of them has a minus. So these are conjugates. So if you wanted to group the x minus 4 part together so that you can tell that it looks like conjugates, we could do that. It's not really entirely necessary, but it may be helpful for you to see that these are indeed conjugates. So now we'll multiply our factors together. Again, start by multiplying your conjugates together. So that x minus 2 factor out front, we're just going to leave as x minus 2 for right now. When we multiply the conjugates, we only need to multiply the real number part by the real number part and the imaginary number part by the imaginary number part, because the other two terms are going to cancel out. So we have, x minus 4 times x minus 4. That's that quantity x minus 4 times itself. So we have to square this term, which really means we have to FOIL it out. So we have x times x is x squared, x times negative 4 is negative 4x, negative 4 times x is another negative 4x, negative 4 times negative 4 is positive 16. That's our x minus 4 times our x minus 4. Then we have negative I times positive I, which is negative I squared. We can clean this up. We can say we have f of x equals that quantity of x minus 2 that we haven't done anything with yet, times, we've got an x squared. We've got negative 8x when we put the negative 4 and the negative 4 together. Negative I squared, well, I squared really means negative 1. So a negative negative 1 becomes a positive 1. So this is 16 plus 1, or plus 17. Now we have a binomial, x minus 2, times this trinomial, x squared minus 8x plus 17. So we'll do our distributing again there. We'll multiply that out. X times x squared is x cubed. X times negative 8x is negative 8x squared. X times 17 is 17x. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 8x is positive 16x. Negative 2 times 17 would be negative 34. And then we just need to combine our like terms. So we have our x cubed. We've got a negative 8x squared and a negative 2x squared. So that adds up to negative 10x squared. let's see, I've got a 17x and a 16x, so that adds up to 33x, and then our minus 34 constant on the end. When we look at this, this is a polynomial function. It's in standard form, highest exponent down to lowest, and all of our coefficients are integers, so we have completed our task here. This is our answer. If you got to a point where your coefficients were not integers, take the entire function and multiply it by something like a common denominator to get rid of those fractions so that you do have integers.